Man, I sure want to know if my house is likely to catch on fire one day. Sure, you can do that with APIs. The apple pineapple ingredient? No, the American Persnickety Index. In 2023, 130 people died in the US from forest fires, one of the highest fire death rates in the industrialized world. For example, the Palisades fire in California just started on January 7th and is mostly over now, which is January 26th. The fire issue in the US is so bad that we even see fires like these in the winter. We see economic losses and destruction of our ecosystem and environment. So, we built an app that predicts the fire risk anywhere in the US using APIs, because preventing the fire altogether in the first place is the best way to fight fires. API actually stands for Application Programming Interface. It's a set of protocols that different applications use to communicate. Developers use APIs to access specific functionalities or retrieve specific data from other systems. So basically, a client uses an API to send an HTTP request via the internet to a server, and the server sends back some data. Here's one example. The client requests some data using this URL. The URL gives the specifics, and the required authentication is also given. The National Weather Service's database will respond with the appropriate data. The response also comes with a status code to tell the client if everything was successful. 200 stands for success, and we all know that 404 stands for not found. It's important to note that APIs have way more functionalities than this. Clients can not only get data, but post, put, or delete data as well. Great. We now have the requested data, and it's probably sent in JSON, JavaScript object notation. It's short and easy for computers to generate and parse. It uses key-value pairs, arrays, and objects to tell what everything means. At first glance, you get this. But after making it pretty, it becomes more readable, and you can use the list format to get the data you need. For example, GridX. Once we got data from the necessary APIs, we trained an artificial neural network using Python. An ANN is a model that consists of layers of interconnected nodes called neurons. Neurons are organized into three types of layers: the input layer, which receives pre-processed data; one or more hidden layers, where the data is processed through weighted connections, activation functions, and biases; and the output layer, which produces the final results, such as probabilities for classification or scores for prediction. In our project, we used an ANN for prediction. Each connection between neurons has a weight, which determines the strength of the signal it transmits. And each neuron itself has a bias, which further modifies data before giving it to the next layer. These weights and biases, called trainable parameters, are adjusted by gradient descent during training through a process called backpropagation. Training optimizes the network to minimize error by iteratively comparing predictions with actual outcomes, sharpening the model's accuracy. More on this is available in my article here. Now, let's dive into our project and see how we used APIs and ANNs to create our web app. Our project involves three main stages: getting the data from APIs, training the AI model, and creating our Streamlit app. First, we wrote getData.py, which takes the latitude and the longitude as the input. Here is now the JSON message from the National Weather Service about a place's weather when we give the latitude and the longitude. We need GridX, GridY, and the CWA to go into forecast hourly. In the hourly forecast, we see the elevation, temperature, precipitation probability, dew point, humidity, and wind speed. We use the hourly forecast because all of the data is up to date and accurate. So now, our code can take any latitude and longitude in the US and spit out these 6 important data points. Next, we use another API link to get the time currently, so that we can use the Meteomatics API, which, given the lat and the long, the forest fire index at that time and location will be spit out. By Mediamatics, the forest fire index estimates the risk of forest fires based on moisture information of 3 different soil layers. The index ranges from 0 to 1, where 0 indicates low risk and 1 indicates high risk. Now we can train our ANN. We wrote datafiller.py to generate a lot of raw data for the ANN. First, we got uscities.csv from simplemaps.com, which is a spreadsheet that has each major US city with its latitude and longitude. Next, we imported what we had from getData.py into here as a function. Then, for each row in uscities.csv, we get the latitude and longitude and use our function to get the temperature, humidity, etc. And store all of this information in a new spreadsheet. We did this for about 700 cities, which is a reasonable amount of data for the small ANN we'll train later. Here's the spreadsheet in Google. After we got the 700 entries, we separated it into the train dataset and the test dataset for our ANN. In the train dataset, we keep the forest fire index because we want our model to learn from its mistakes as it tries to get the same forest fire indexes as what we provide. In the test dataset, however, we deleted the forest fire index because we want to test our ANN. Now, we are fully ready to train our model. We trained our model using Python on Google Colab. We uploaded our files here. Now, let's skip all the way down to here. Here, our input layer will have 8 neurons. Lat, long, temp, hum, etc. Our hidden layer will have 8 neurons. And our output layer will have 1 neuron, which is the predictive forest fire index. We use ReLU and sigmoid as the activation functions, and mean squared error as the loss metric. From a validation set, our MAE was 0.146, which can be improved with more inputs and tweaking of the ANN parameters. Here is the test data set. Let's see what it predicted. For example, for row 0, the right answer was 0.1. For row 2, the right answer was 1.0. And for row 4, the right answer was 0.0. As you can see, our model is quite accurate. So now that our model works well, we put our model into a Streamlit app. First, we downloaded the model and the scalar of inputs up here. Then, we imported them and used st.write to create our app interface in app.py. Next, we put all of these files into a GitHub repository and used it for Streamlit. The result? A fully functional Streamlit app for the public and the government to use. The link for the app is in the description below. Thank you for watching. We hope you enjoyed using the apple pineapple ingredient to predict fire risk all over the USA. No, it's the American Persnickety Index. No! Oh!